Hello, my name is Steve Quirn. I'm the creator of the Flowchart Project Man Spacecraft design concept. Today I'm going to continue on with my multi-motor engine design for the Flowchart Project Yamato spacecraft design. The FCP Yamato is a thought experiment in what an Earth-Mars colony spacecraft would look like. Here's a thought exercise. So it's not an actual, the Flowchart Project Yamato is not meant to be an actual spaceship design, such as the Apollo 75 space vehicle or the Nova rocket for the Mars Direct 3.0 for the Mars Direct program. Okay, so let's see here where we're at. Oh, I got the unhide that. So that's what that, okay. So that's what the hull looks like. Wait a minute. So that's what that looks like. And the engine is within the part of the hull volume of the World War II battleship Yamato. This is a generic volume mass. So let's see here. Hide that again. Now these are rocket motors, and so these are 5-foot motors, what I refer to as 5-foot motors. I'm not a rocket scientist. I'm not in contact with NASA or in the outer space community, so I know nothing about rocket designs or anything. And actually at this stage, I'm just working on theoretical concepts for visual graphics presentation, so the actual numbers does not really matter. But having something that's close to reality is relevant. So this engine nozzle is 30 feet in length, 30 feet in diameter. So that's how, and the F1 engine nozzle, it was 8 feet in diameter, so yeah, it's a big one. It's a big one. So this volume, yeah, you look at it. This volume is 15 feet by diameter, or yeah, 15 feet diameter from here to there. From this edge to that edge, from this edge to that edge, 15 feet in diameter, or length or width, whatever you want to call it. But if you're looking at the nozzle end, if you're looking at the nozzle, it'd be diameter. What the heck? What did I do? I touched something. So basically what I'm going to be doing with this project is replicating this. But each, instead of using S1C stages, they're going to be replaced. The S1C stage is going to be replaced by a propellant system that uses the 30-foot diameter nozzle with the four 5-foot engines motors that act as a singular engine. So that's what I'm working on. Okay, we need to get out of that. Skipping process causes problems, so we want to, exit. We're going to have to exit the application for a bit. 2001, 2002, 2003, 2004, 2005, 2006, 2007, 2008, 2009, 2010. Giving it 10 seconds gives the computer time to do whatever it needs to do. And multi-motor. So that's what I'm going to be attempting to do. Wrong one. Is that a habit for trying to go down here? That might be habit from working with version 1 and version 2. I'm not sure what's going on. And that is a new thing that's happening to me. Okay, we're going to do a cube. Material. Engine motor. Scale it. It's a 5-foot motor. Wrong 5. Okay. Let's move that to 150. Is when we look at go on top. I do not have any scripts. I have not created a script for this project. What I'm going to say, what I'm going to do. I have no paperwork on the numbers and position, numbers of object sizes, the distance of the objects, the models, model sizes, the distance between models, and the positions that they are supposed to be in, and the angles that they're supposed to be at. I have none of that. I am just doing this on the wing. I have thought about some of the things I was going to do here, but it's all in my head, and so cylinder material. Oh, I need to rename it. Nozzle. Cube. 5-foot motor. Okay, this goes here. Hide the hole. Wait a minute. I'm getting a little scatterbrained here. Let's make another. Okay, we got a cylinder. Skillet. Since you're using a 5-foot. Come on, wrong one. Get in there. 5-foot motor means a 10-foot nozzle. A 5-foot motor, we'll move that over X50. Let's move it back to 0. Just move it back to 0. Oh, wait, we gotta get that out of there. I'm making a new object. Do you want to make new objects? I guess, okay, we need to rename this. Engine nozzle. It's got 1.1. Nope, this should be 1.0. Okay. We need to move it. 150. And then we make another model. Scale it. .1. Since it's a 10-foot motor nozzle, it's a 5-foot motor, so Oops, wrong one. Okay. All of that. Delete that. Okay. Nozzle. All of that. Skillet. Come on, behave. That. Okay. That goes bye-bye. The body does not stay, so does not stick from project from. And I need to save this. Exit app in order to save. 2001, 2002, 2003, 2004, 2005, 2006, 2007, 2008, 2009, 2010. Let the files do the happy stuff. Okay. There's more. Okay. Sender goes bye-bye. Worthless. Can't use it for other things. So, back in version 2, I had first things I did. Let's get out of this. I create the project name. This got jacked up. I created a model. Well, what I created 2 models and I had to destroy everything. It got jacked up, so I had to delete the model and create a new one. So the first thing I do in version 2 was create the project name text, then a scale text. I had, on some projects, I had 2 or 3 scale texts. Then I would make measure models, measure cube, measure cylinder, and measure spheres. And what they did, and because if I was stuck, if you make this a 5-foot cube, and then you later decide, oh, I want it to be a 1-foot cube, 1 foot by 1 foot by 1 foot, then you could, and then it'll stay there until you change it again. And the same thing with these others. And you destroy a block face, it stays. Now you can't refill the empty space, but so what I did in version 2 was I created a cylinder, the measure cylinder, and use that to make one measure, and then do that, and then resize it to make different sized nozzles. Also, I use it for measuring distances and diameters of objects and spacing between objects. And I use these for making measurements between objects. How big is everything? Usually I use the cube here, but then sometimes I use the cylinder depending on what I'm playing with. Spheres come in handy. I don't always use spheres. Sometimes I do, sometimes I don't. I fluctuate. I've always have this, the measure cube, and these 2 fluctuate as to whether they exist or not. Let's see here. And so I had a measure, so I had these, so these would be the first 3 or first 5, well, not always the first 5, first 3. The cube is not, usually the cube was the first 3, but sometimes I make objects, then, I need a few, then I eventually make one of these and make one of these. But I eventually had these in my projects, and I move them around, resize them, relocate them, and stuff. I'm using it for the time being, and then I start making. So having those for construction of the objects, it was really beneficial. I really miss that. Okay, face it. And because creation, deletion of objects, if you're going to have to exit the programs to save your progress. Otherwise, your application gets jacked up. Since I deleted things, okay, I'm going to exit the application. This is the arrow key is the proper way of exiting the app. This is not the proper way of exiting the app. 2001, 2002, 2003, 2004, 2005, 2006, 2007, 2008, 2009, 2010. I'm not frustrated right now or anything, so it's not, the 10-second wait is not a big deal for me right now. And the last session, I did get frustrated, and it became an issue, but So now how do you want to play with this? Okay. Engine nozzle. Move it to 100. Move to 0. It's at 5. Okay, wait, no, that's a 10-foot nozzle. So it's at the 5 point, the center line. So if I go down 2.5, minus 2.5, five-foot motor, move it, 2.5. Nope. I gotta do the whole 5. That way it's balanced. 2.55, 2.55. So what I have been doing in my previous projects was using the motor. This is a 5-foot motor, cryogenic, liquid hydrogen, liquid oxygen, multi-start, variable thrust. Create a model. Okay, so okay, that'll work. Material. New material. Color. Up. Okay. You name the material. Wrong one. Right one. Fuel tank. This is the volume of fuel. Oh, material. We need another one. Color. Transparent. .5. Rename that. Fuel tank transparent. Well, I usually use it for the fuel tank framework. But if I want to use a solid structure to, if I want to, I was going to do the fuel tank transparent. If I decide to, I want to do make the fuel tank structure. No, okay. I was thinking, oh no, what I do, no, that's not. Could we rename that? Fuel tank structure. Fuel tank and rename. Let's just go with exterior. And oh wait. Okay. Move it to 100. Okay, scale that. I'm on values. So let's go with 15. Do not delete that. If I delete this thing, I'm going to have to start again because values don't stick. Now what I try to do is create a sphere that encompasses the entire engine. So I'm going to say this is 18. If I have notes, then if I kept notes, then I would know what this value is. I think it's more like 17.5 or 17, you know, I think it might be in the 17 range. Okay, let's do that. And I gotta move the sphere down a little bit. For the sphere to properly encompass the entire structure. Okay, so 17 is the wrong size. Move it -1. -0.5. Okay, so since I can't, because the value don't stick, scale it. So it's, how do I get it from 17 to 17.1? Because 17 is value of 1, I gotta do some very complicated mathematics, which is what I'm not going to do. So, bye-bye, sphere. Sphere. Model. Oh man. Color. Hit that. Transparency. Okay. 0.5. Rename. Exit that, just to make sure that I don't lose it. I may have had to, because I renamed that thing like multiple times. I may have had to exit it, but I don't know. It may or may not have saved it. Who knows? PRISMA3D is kind of whacked. Okay. Okay, move it to 100. Nope. So we're going to scale it now. Oh, we got to move it again. Minus 0.5. Seventeen point one. 17.1. 17.1. Yeah, that's not going to work. Yeah. 17.25. That was not going to work. Oh 17.5, 17.5, 17.5, it's all encompassed, not quite. Move it, negative 0.75, yeah, 75. Okay. Negative 1. Oh. Okay. Maybe 0.25. Okay, I was, okay. Negative. Okay, that's, negative 0.325. 5 numbers. Okay, 315. Wait, no. Yeah, 312. Oh, 337. I guess there's 3.4 and 3.5. 8.2. Okay. So I see a hint of penetration. Eight five. Nine. Oops. Nine five. Going up, not going down. Okay. Nope. And because of all this changes here, I'm going to have to exit the application when I'm done with this. Happy stuff. Is there a hint of penetration? No. Wait. Yes, there is a hint of penetration. Mm-hmm. Sphere one text, nope. Sphere, yes. Move. 143. That's concealed. Not quite. Oh. Okay, wait a minute. We gotta see what happened on the move. Okay. Okay, nothing got moved. Okay. Sphere. Okay. Get out of there. Sphere. Move. 4-2. That's concealed. That's not concealed. Okay. Here. Move 4-5. Scale it. 17.5 was the scale value. Okay, that's concealed. And that's concealed. So, okay. So 17.5, wait. Okay, whatever. Okay. Close enough. Whatever. Okay. So 17.5 by 17.5 by 17.5 17.5 diameter sphere is equivalent to, based on this calculation, is for one 5-foot motor. No. Delete that. Undo that. Do that. No, no, no. What the crike? Undo that. Oh, that's the fuel. Don't tell me I renamed the sphere wrong. Senator. Oh man, I named the fuel tank the fuel motor. Okay. Yeah, okay. Delete that. Sphere. Material. I was hoping that making these blocks, doing it that way does not get rid of that, but I don't know. PRISMA3D is inconsistent in how it behaves. Fuel tank exterior. Move it to 100. Move it -1. -0.5. -25. Oh, okay. Oh, I'm just moving it. Wait, no. -6. 0.6. There's a little bit there, and there's a little bit there. -6.5. Let's see how that changes there. That seems about equal. 17 is the whole number, so we're going to leave it at that. Simplify things. Okay, so this field volume, 17-foot diameter, spheric diameter, based on my theories, is equivalent to 50 minutes of fuel for this 5-foot motor engine. Now we have 4 engines. So we need 17 times 4 tanks. Now, okay, this requires physics on geometric mathematics that I do not have skills in. So that requires okay. Rename five-foot motor fuel tank. It's rotated 90 degrees. All that's okay. So, all right. We're going to move you up to 100. Oops, 200. And we're going to move you to 300s. That's 400. That's not good. So that's 193. Wait, that's 5. Yeah, 197. Whoops. 200. That's correct. 397. Okay. And that's 17 divided by 2 is 8. Nope. 16.5. Wait, 8.5. That's 89. 87, 88, okay. So times 4. How do you increase the scale on this thing? Okay, let's move this thing again. Decide this for the time being, and let's get these motors numbered. What are you? Nope, you are not that. You're that. Rename top. Your bottom. Nope. Your left. Your bottom. And nope, you are not that. You are that. And you are right. Rename. Unhide. Now what I can do to simplify the process is to leave the scale as is. And just duplicate it. It's 17, 71. Wait a minute. Okay, so that's times 2. Copy, move it, 17, 6, 4, 5, 4. Oops. Copy that. Wait. Oh, yeah, whatever. Move it, 17, 4, 3, 7. We're going to keep those two together for the time being. Create all cylinder, fuel tank, 90, move it to 200, go to 300, okay, we go to, let's get back to default, something where we're looking at. Move to 400, $350, 360, this is 365, scale it, 17, okay, okay, now transparent that. Ooh, 362.5. Okay. Now scale it. 17 times 3 is 21. 3 plus 2 is 5. 51. Material, fuel tank interior. Five-foot motor fuel tank. Okay, we're going to do that. And name it 5-foot motor fuel tank mid. Not mud, mid. Not Mike, mid. Okay, now we're going to move it. 36.2, 36, yeah, 362.5. 362.5. All right. Actually, you can keep that distance. We just go 0, 150. Center that. Model that. Delete that. Down there. Rotate. Delete that. Get out of that. Since we deleted faces, let's exit the application. Exit. Thank you. 1001, 1002, 1003, 1004, 2005, 2006, 2007, 2008, 2009, 2010. All right. Make sure we hit into the correct ones. Did that. Did that. There you go. So this is 15 minutes of fuel for this motor, for this engine. Theoretically. Rename that. Move it. $150. Okay, 0 level is the work area. Since this is the bow, we're going in that direction. We're modeling it. Okay. Delete now that. Get that in a moment. Exit. Actually, I should have. Oh, oops. Bow. So we are going to get rid of these 3 sections. Delete. Give ourselves a basic helmet. Delete that. Come on. Rotate, rotate. Not that way. Come on. Whatever. Delete. Hang up. Okay. Delete. Oops. Delete. Get all that. Exit. (1001), (1002), (1003), (1004), (1005), (1006), (1007), (1008), (1009), (1010). There we go. Fuel tank bow. 200. There we go. Rename. Zero. 150. Let's find it. Well, nope. Stern. Do that. Delete. Yeah, I gotta figure out how to redo that segment here. Reposition my videos so you can see it better instead of on an angle. It has to be more behind my head, but then if it's behind my head, I can't see it. Can't see if I'm doing what I'm doing wrong on the videos. Exit 2001, 2002, 2003, 2004, 2005, 2006, 2007, 2008, 2009, 2010. And we're doing down here, stern, nope, stern, move to 100, zero, and that's that. Now, okay, so let's move everything by 10 feet. Eight. Move 27. And this is why I would like to be able. I like the version 2 reorganizing system. Let's go with 5 to simplify that. Okay. Reposition these. Okay, now how far is it on the video? 1 hour and 39 minutes. Okay. Now with version 2, what I would be able to do is take this, copy it, scale it, and change the numbers and have a new model. But I cannot do that. And then rename the model and reposition the model. So, delete that. So I have to create a brand new model. And remember what the dimension of this model is. And then add 2 feet to that measurement. Not a note taking if you're doing this procedure, project properly. Sphere. Scale it. 19. Excuse me. 19. 19. 19. New material, because this is a fuel tank, oxidizer tank. Oh, that's in the black. Okay. Okay. Fuel tank interior. Nope. Oxidizer tank interior. Rename it. I hit the wrong button because I have where this was positioned on the screen. Cover. Yeah, that's correct. Rename it. Oxidizer Tank Exterior. Okay, we go that route. We're going to save. Okay, just get out of that. We're just going to save that because we lost some earlier today. We lost the material. Let's see if we don't lose it again. Oh, I didn't do the second thing. 2001, 2002, 2003, 2004, 2005, 2006, 2007, 2008, 2009, 2010. I don't know. Okay, let's see what we got here. Sphere, material. Oh, I didn't rename it. Okay. Rename it Oxidizer Tank Exterior. We're going to change it to interior because that's what it is. Delete models. Oh. Fuel tank stern. Copy material. That is my also my interior. Rename it Oxidizer Tank Interior. Move it 278. I don't know how many feet I gotta actually move it. Yeah. Rename it. Let's save that. 2001, 2002, 2003, 2004, 2005, 2006, 2007, 2008, 2009, 2010. Unhide that. Change the material to transparent. See what we're playing with. Hide that. Okay. Good. Copy. Material. Move it to 100. So that's 2. Rename that. Oxidizer. Now, oh, this is going to be interesting. So, my theory on fuel consumption, or correction, propellant consumption of the cryogenic fuel, liquid hydrogen, liquid oxygen, is 1 fuel per 2 oxidizers. 1 hydrogen per 2 oxygen as the maximum burn. So we're going to have 2 tanks of the same volume instead of 1. I don't know if that's correct or not, but that's the assumption I'm going under. Again, I'm not a rocket scientist. I'm not in contact with the outer space community so I can get precise information. This is just a general concept. Details like that are not actually important. It's just, specific details like that is not really needed because this is a theoretical concept, a thought exercise, and not just design this thing in real life. What would this look like in real life? How practical is this? Is this a practical design? It's a generic. It looks good, but okay, I'm going to do the numbers. These numbers are wrong, and okay, so how wrong is this? It's 50% wrong, 75% wrong, 100% wrong. Scrap it. 25% wrong, 15% wrong. It may be doable. 10% wrong, it may be doable. 20% wrong. Now, if we're doing metric systems, if it's 20% wrong, it's like, you're out of here. But if it's, if the numbers are about 10% off, it's doable. But with with the American system, that's it with in metric. If it's 10% off, it's doable. But if you're 20% off on the metric system, ain't gonna fly. With an American system, you're 20% off, there's a chance that it can fly. It's just, you want to take that chance? Maybe yes, maybe no. So, and bow. Copy. Move. So there's that. And we'll do it again. But we need to look at this. We got to look at how we're naming this fuel tank. I mean, the oxidizer tank. Oh, we didn't rename it. Okay. Okay, this is going to go with back oxidizer tank. And I forgot to name you. Okay, since I did some of that, just save that. Exit. 2001, 2002, 2003, 2004, 2005, 2006, 2007, 2008, 2009, 2010. Okay. Okay, that did not hold. Nope, that, okay. Okay, rename it. I'm trying to figure out what to rename these guys. This section here. So exit that. Multiple renaming did not work, so I was going to do single renaming. Saves. 2001, 2002, 2003, 2004, 2005, 2006, 2007, 2008, 2009, 2010. Once I get the second fuel tank made, I'm ending this project, this video session. There we go. Rename it. I don't know all the idiosyncrasies that this thing has, but you know, frequent saves. I don't know what to think about. Oop. I gotta give it a little time to redo its stuff. And since I'm talking, I'm not counting. Since I cleaned out the memory on this tablet, PRISMA3D has been working pretty good. There are idiosyncrasies due to the coding and design philosophy. And I'm not sure which is which on some of these errors. But saving frequently helps also. How often you save does determine how often you think. If you don't save very often, PRISMA3D will glitch a lot. So there is some. Oh, that's an oxidizer tank now. Back oxidizer. So now in version 2, I did have issues with Oxidizer. I did recognize that infrequent saving did cause problems on the with the project. So it's 2001, 2002, 2003, 2004, 2005, 2006, 2007, 2008, 2009, 2010. So the saving issue is not. But then any app, this is true with Blender 3D even. You have to save kind of frequently, otherwise things get haywire. But the bigger the computer system is, as far as CPU operations and memory, the more you can, the less savings you can need to do. But the more activity you're doing on a project, the more you have to save. So frequent saving is recommended. Adding an autosave feature is just complicates the thing. PRISMA3D. Oh, I forgot to save it. It's all dead now. Well, I write. Okay, I do a lot of writing, literary writing, and I'm not talking. All right, let's get out of this. Oh. Okay, I had a lot of projects on the. Okay. Yes. NOTEPAD free. Okay, let's go on the vertical. Let's see how this. Okay. Now, these. Okay. Okay. Ultimate Admiral Dreadnoughts. This is. Okay. Dreadnoughts multiplayer 1. This is let's see here, multiplayer 1. Let's do this. Wait a minute. Get all that. I got player 1, player 3, multiplayer. This is the original. Page 1 of 18. Okay. Page 1 of 18. Okay. And one page. Okay, this is, well, this is how many, one printout. From here to the top is one printout. From this double line, we're gonna have to. From this double line here, the bold double dark, bold equalizer line, equal sign line, to this bold equals sign line is one page. Actually, page 1 to page 1. Page 1 of 18, then to page 2 of 18 is the second page. And then this represents the top of the. Okay, so page 1 would have this all the way down to page 1 of 18. Page 2 of 18 would have this all the way down to the the bold equals sign line. So yeah, this is huge. What to do? Okay. Well, page 3. Well, these double lines represents different sections of the document. This is the front page document, which is their basic information about the document. I don't have a list of authors and editors on this one. Okay. As if there's other people editing and authoring this text. The edit dates September 30th, 2024, October 1st, 2024, January 2nd, 2025, January 3rd, 2025, January 4th, 2025, February 17, 2025, February 18, 2025. Ooh, I did a boo-boo there. There you go. And today's date is January 13th, 2026. 13. Where are you? Oh, you are lagging. Oh, this is a huge lag, so it's lagging a lot. Plus, there is '20, '26. That's okay. So, let's see here. Small belt. Okay, these are table of contents. Letters to Stealth 17 Gaming. Dreadnought. Okay. Everything, 90% of what I know about Ultimate Admiral Dreadnoughts was watching YouTube videos made by Stealth 17 Gaming when it comes to Ultimate Admiral Dreadnoughts. Panzergraph, Stealth 17 Gaming, and Hipper 98YT did a video. So here's the numbers that I got from their videos. Bro Silly did a thing. I got numbers from his videos. Here's more Panzergraph video data. Brother Monroe's data that I got. The are you Duismoth? Duismoth? Whoever that is. I think the data that I got from him is the same as the previous data, I guess. I don't know. Maybe that's why there's nothing there. It's Ripete. Admiral Finn data. Or maybe I just didn't look at it. I don't know what's going on, why that's blank. Still 17 Gaming data. So based on the previous data, I came up with a pre-dreadnought era small battle. This is an early version of the campaign, not the campaign, player versus ultimate multiplayer DLC. This is the early version of the multiplayer DLC, player versus player battle. And so I did I looked at the numbers and I did the calculations. Did some calculations on the 55. Let's see here. Maximum tonnage for a small battle is 30,000 tons. The maximum cost of your fleet is $125 million. And the maximum ships you can have is 15. So you can have 15 2,000-ton ships. So 15 divided by 35 is 2,000-ton ships. 15 ships divided by 125 million is $808,333,000 and 333,333 per ship. And then tonnage per cost, you can have $4,166 per ton per ship. So the $8,333,333 per ship is, it can fluctuate higher or lower, and tons can fluctuate a little bit higher or lower, but these are calculations. So based on these base generic calculations, you can have 15 DDs, a destroyer being 2,000 tons, each destroyer costing $8,333,333. And I have this destroyer design is a small ship hunter. It's a high seas fleet small ship hunter. And then there is there's another fleet concept with one heavy cruiser and 11 DDs, or armored cruiser. Wait, since this is since we're dealing with pre-dreadnought campaigns. Yeah, since they're pre-dreadnought, it's an armored cruiser, not a heavy cruiser. An armored cruiser. It's a mini battleship design for the high seas fleet. It's 8,000 tons, 8,500 tons. That's the sum within the campaign, within the Ultimate Admiral Dreadnoughts campaign. Some nations, shipyards have a map at the start of the game, January 1880. Wait, nope, 1890 is when 1880. 1890 is when Harvey Steels came out. So a year before, 10 years before Harvey Steel came out, which is 1880. Some nations have a maximum of maximum size of the shipyard is 8,000 tons, 8,500 tons. That would be there's two or three of them. Austria-Hungary is one of those. There's another, and then the largest, if I remember correctly, and the largest starting naval yard is 10,500 tons. So you can have a battleship for 10,500 tons at January 1880. So that's where these numbers are coming from. And from that, you have one armored cruiser, and then 11 destroyers. One destroyer is a Fleet Scout, High Seas Fleet Scout, and 10 destroyers on the 1CA and 11 DDs. Is a 2,000-ton High Seas Small Ship Hunter. Then you have a BB, one battleship, one armored cruiser, and 6 destroyers. And I have a 10,500-ton battleship design, which is long-range support, high seas long-range support design. I have the armored cruiser, which is a mini battleship high seas design, which is 8,500 tons. And then I have a 2,000-ton high seas small ship hunter design. And I have 2 destroyers that are high sea fleet scouts. They are 1,500 tons. The mission rule of a small ship hunter destroyer is different from the mission rule of a fleet scout. The primary role of the fleet scout is to get out there and see the opponents, look for enemies and stuff, to catch up. If you got near the end of the game, in the battle scenario, there's a lot of, I never played Ultimate Admiral Dreadnoughts, I just seen people play it, and there's a lot of a lot of times where they're chasing down enemy ships that have gotten away from them, and so the Fleet Scout would help with chasing them down, and they have battleships that can hit them, but they don't have the sight range. You need to have another ship out there to see them, to have the artillery. They have the artillery range, but not the sight range. So you have a ship that can see them, but it's beyond the side of the battleship. They can now talk to the battleship and say, "Oh, the battleship can hit the thing," but you have to have radio communications for that. Or maybe the battleship can see the Fleet Scout, and the Fleet Scout can see the enemy ship, and then the battleship can hit the fleeting enemy ships. So that's the primary role that the Fleet Scout does. It finds the enemies, determines what the enemy formations looks like and stuff, and to help determine how you want to deal with the enemy. The small ship hunters is basically they hunt down merchant ships, they hunt down other destroyers, cruisers, light cruisers, unarmored cruisers, back in the pre-dreadnought area. Your light cruisers are what was considered as light cruiser is an unarmored cruiser, and small armament cruisers. There's variations in what was classified as a light cruiser, but so your light cruisers back in the pre-dreadnought areas would be equivalent to unarmored cruisers, cruisers with low tonnage, and cruisers with small guns, and or. Because back in 1880, pre-Washington Treaty of 22, there was no standardization between nations. Each nation had its own standard, and the standard, so it was a confused mess as far what was the ship, what counts as an armored cruiser or a heavy cruiser, and so they didn't, the terminologies fluctuated on ship designs between 1860, when the first iron hull came out. The Monitor and the Virginia was changed to the Merrimack. The Monitor versus the Merrimack. And so the 1860s, so that happened in the 1860s, and Harvey Steel came out in 1890s. So Then we have got a long-range battleship support. Light cruiser is a small ship hunter that hunts down for the. So these destroyers are not. Well, they're torpedo boats. These small ship hunters are equivalent to torpedo boats, high seas torpedo boats, but they have other gunnery also. Basically, small guns between 3-inch guns and 6-inch guns in size. Anything under the 6-inch guns. So basically, usually I have them armored between 3-inch guns and 4-inch guns. All those 6-inch guns would qualify for, although pre-dreadnought destroyers do not have 6-inch guns, so you can't mount a 6-inch gun on there. Now you can make a 6-inch gun and then downscale it to 5.1 inch. Maybe you can put it on there then. I don't know. I don't think so. I haven't seen anybody try that. But then it's been a few years since anybody did an Ultimate Outdoor Dreadnoughts video. So yeah, so they have the small battle, pre-dreadnought small battle, and then we got a pre-dreadnought medium battle data, pre-dreadnought large battle data, and then the calculations for the warship size, designs, and costs. And then the original document data. Oh. Okay. I must have done some changes here. Original document data, what does this include? Battleship configuration, tonnage, costs, selected battle, selected feet. Okay, in the original version of the DLC, multiplayer DLC on the Ultimate Admiral Dreadnoughts, you had you can create a fleet. You design warships, and then you put them in a fleet, and then you have a selected fleet, and then they're designed for a pre-dreadnought campaign or dreadnought campaign, World War I campaign, World War II campaign. And so, let's see here, and then, so these were some of the battleship fleet national. Let's see here. Oh, fleet types selected. These are the ship designs that would be in a fleet that would be available for your fleet. I think, yeah. Nationality, ship type, year, the year that is designed, the technology year of the ship, basically. The ship name, tonnage. And then the costs. So Canadian, that's my default nationality. It doesn't matter which nation I use. I'll be doing these designs, and each nation with an Ultimate Admiral Dreadnoughts has its particularities in terms of hull shapes, hull functions, and weapon system mounts on the hulls, and hull performance. So, so there's variations in this. So what a torpedo boat dog, okay. Broadside torpedo boat. Let's see what this stands for. TB, broadside port defense, okay. An 1890 port defense broadside torpedo boat is a minimum size TB, has a single torpedo tube on the port side, and has a single torpedo tube on the broadside, and its range is minimal. It has zero range, which depending on how you do the ship design, is somewhere between 1,200 kilometers and 2,500 kilometers maxed out. So generally around 2,000 kilometer range. Then you have the centerline torpedo boat, which is the CAT series. And these came out to 895 tons. Oh, these are calculated tons. Again, I don't know the actual numbers, but then what a dog looks like, what a dog torpedo looks like, Germany's would be different from the French dog, from the British dog, from the U.S. dog, from the Italian dog, from the Japanese dog, from the Chinese dog, from the Russian dog, and from the Austrian-Hungary dog. So that's why, and then this is what the dog looks like, based on what I've seen on the design concept. So I studied military technology and history back in the 1980s when I was in high school. And by the time I graduated high school in 1985, I came up with some designs, warship design theories. And concerning destroyers and cruisers and battleships and stuff like submarines and stuff. And when I played when I played Navy Field and between 2012 and 2016, the warship designs that I was using, the armament arrangement I was using, the way I was firing my guns on my warships, and the way I was the sailor training was not, but how I changed the armor, how I did the armor layout, how I did the engine propulsion systems, what kind of weaponry I used. That was all based on my 1980s theories. So, but All-Twin Admiral Dreadnoughts goes even further, and I can do with Navy Field, and same thing with World of Warships and all these World of Warship copies, is you're playing with a pre-designed hull that is, that you kind of fluctuate. And you're not really playing with World War II warships or World War I warship designs. That's a lie. So, but what Ultimate Admiral Dreadnoughts does, I can configure the guns where I want and stuff, and so I can simulate roughly, sort of simulate a Bismarck, sort of simulate a Hood or an Iowa, sort of. But then I'm not interested in simulating realistic warships. I have my own warship design concepts and theories that I would like to test against them. And so Ultimate Admiral Dreadnought looks interesting in that. But Rule of the Waves is a better game system in terms of ship design mechanics, I think. But what Ultimate Admiral Dreadnoughts is a visual graphics-based game system. Rule of the Waves is a text game-based system. So you don't have the visual graphic details that Ultimate Admiral Dreadnoughts has. With Rule of the Waves does not have the graphics that the Ultimate Admiral Dreadnought has when it comes to warship design. So Ultimate is much more pleasing as far as this is what my ship would look like. But you can't mix national technologies the way I would do on my warship designs. So, and that mixing of technologies goes back to my 1980s design theories. So, this is the end of the text. So I got a destroyer, transport hunter, destroyer, 1890 transport hunter. And then I have an armored cruiser, mini battleship, port defense, which is basically a it tries to be like the Monitor, and or the well, there's a Monitor version. That's the Monitor version, and there's the then there's the Merrimack version. So that's the cat. And that's the dog. So those are the worst designs I got made. Or I want to make here. Here's the worst designs that I still thinking about. So yeah, there's when you do it all, you gotta do a lot of saves. When you're doing a text like that, you have to save and save and save. Saving is very important. So now we are at 1 hour and 37 minutes. You go to the model. Let's go like this. Everything's good there. Everything's good here. Back Oxidizer Tank System. Okay. Copy that. Just moving another 100 feet. Material. Interior. Rename. Front. Exited that. I said exit. (2001), (2002), (2003), (2004), (2005), (2006), (2007), (2008), (2009), (2010). So yeah, I think a lot about things. So this is not designing things is what I do. Rename front. Rename that. Did not work out right. What the crike? Where'd you go? Get out of there. What did I hit? I hit something up here. Okay. Exit. Yes. 2001, 2002, 2003, 2004, 2005, 2006, 2007, 2008, 2009, 2010. Okay, that's good. Okay, that's good. New tank. Copy. Move it 100 feet. Rename it. Exit. Exit. 2001, 2002, 2003, 2004, 2005, 2006, 2007, 2008, 2009, 2010. Okay, I did not color code that thing. Color code it. Copy. Okay. Thousand one, 1002, 1003, 1004, 1005, 1006, 1007, 1008, 1009, 1010. So apparently what happens is you copy a model and you move it around, do changes to the model, and you try to rename it, then renaming does not stick upon the save. So you have to come back and rename it and then exit the thing. Before I can continue on. So rename that. Rename that. What? The crike. Well, the misspelling is due to where it's positioned. This side is not very good for me as far as hitting the keyboard. Now let's exit. Thousand one, 1002, 1003, 1004, 1005, 1006, 1007, 1008, 1009, 1010. Visual graphics is good. Nope, it did not stick. Your name. I'm wondering if the reason it's not sticking is because I'm using this instead of this for OK. In version 2, if I remember correctly, you type this, you press this, and you still have this text here, and then you say, okay, yeah, you did that because I caught mistake. I did this, and I saw the mistakes, and I was able to go back and reactivate this keyboard and then fix the text. So yeah, yeah, that's the reason. So maybe that's what's going on there on the naming conventions of this thing. The protocols are different now. Maybe I need to look at that. There, it's stuck. Okay. Now it's time to make a screenshot. Before I do the screenshot for the thumbnail. So that's what that looks like. And then that's what that looks like. So I'm going to have to make a hull model material and framework material for this. Eventually, but that's not a high priority right now. So so that's it. Now it's time to make the thumbnail.